Our story begins in the vastness of space. Over 4.5 billion years ago, imagine a swirling cloud of gas and dust, remnants of a long-gone star. Gravity drew this cosmic dust together. Particles collided, generating heat. A fiery core ignited. A star was born, our sun. Around this star, dust and gas swirled in a chaotic dance. Particles clumped together, forming larger bodies. Eventually, these clumps grew into planets. Among them was a young, fiery planet Earth. Covered in molten rock and bombarded by asteroids, early Earth was hostile. But within this chaos lay the seeds of life, waiting to emerge. While Earth was still in its infancy, a cataclysmic event occurred that would forever shape its destiny. A Mars-sized object named Theia collided with our young planet in a fiery embrace. The impact was unimaginable, melting Earth's surface and blasting debris into space. This debris, caught in Earth's gravitational pull, began to coalesce. Over time, it formed a celestial dance partner for our planet, the Moon. The Moon's gravitational influence stabilized Earth's rotation, preventing wild swings in climate and creating a more stable environment for life to evolve. The Moon's presence also created tides, rhythmic rises and falls of ocean water, which played a crucial role in shaping coastal environments and influencing the evolution of marine life. From this cosmic collision, a celestial ballet began, a dance between Earth and Moon that continues to this day. As Earth cooled, its molten surface solidified, forming the first continents. But something extraordinary was happening. Volcanoes erupted, spewing gases and water vapor into the atmosphere. This water vapor condensed and fell as torrential rain, filling the planet's basins and creating the first oceans. These early oceans were not the serene blue expanses we know today. They were hot, acidic, and constantly bombarded by asteroids. Yet within these turbulent waters, the miracle of life would soon emerge. The oceans became Earth's first cradles of life, nurturing the first single-celled organisms that would eventually give rise to all life on Earth. The stage was set for the next chapter in Earth's story, a chapter filled with microscopic wonders and the slow, inexorable march of evolution. Early Earth's atmosphere was a far cry from the life-sustaining blanket of gases we breathe today. It was a toxic cocktail of methane, ammonia, and carbon dioxide spewed out by volcanic eruptions. However, life itself would play a pivotal role in transforming this toxic atmosphere. Around 3.5 billion years ago, a remarkable group of microorganisms called cyanobacteria emerged in the oceans. These tiny organisms possessed the extraordinary ability to photosynthesize, using sunlight to convert carbon dioxide and water into energy and releasing oxygen as a byproduct. Over millions of years, cyanobacteria released vast amounts of oxygen into the atmosphere. This great oxidation event transformed Earth's atmosphere, paving the way for the evolution of oxygen-breathing organisms and eventually leading to the complex life forms we see today. Section 5. Life finds a way, the spark in the primordial soup. The exact moment when life first arose on Earth remains one of science's greatest mysteries. However, we know that within the warm, nutrient-rich waters of the early oceans, a remarkable transformation occurred. Simple organic molecules, the building blocks of life, assembled themselves into more complex structures. These structures, perhaps resembling tiny bubbles or droplets, eventually developed the ability to replicate themselves. This marked the birth of the first life forms on Earth, simple, single-celled organisms. These pioneering life forms were incredibly adaptable, thriving in the harsh conditions of early Earth. From these humble beginnings, life would embark on an extraordinary journey of diversification and complexity, eventually giving rise to the incredible biodiversity we see on our planet today. Section 6, from single cells to complex creatures, the rise of diversity. For billions of years, single-celled organisms were the sole inhabitants of Earth. Then, around 600 million years ago, something extraordinary happened. Cells began to cooperate, forming multicellular organisms. This marked a pivotal turning point in the history of life. With multicellularity came a burst of evolutionary innovation. Organisms evolved specialized cells and tissues, leading to the development of organs and complex body plans. The first animals emerged in the oceans, followed by plants colonizing the land. Life was no longer confined to the microscopic world. It was becoming larger, more complex, and infinitely more diverse. Section 7, the Cambrian explosion, life's Big Bang. Around 540 million years ago, life on Earth underwent a dramatic transformation. In a relatively short period known as the Cambrian explosion, a dazzling array of new life forms appeared. Creatures with shells, skeletons, and complex sensory organs evolved, filling the oceans with an unprecedented diversity of life. This explosion of life was driven by a combination of factors, including a warmer climate, increased oxygen levels, and the evolution of new body plans. The Cambrian explosion marked a turning point in Earth's history, establishing the foundations for the complex ecosystems and the incredible biodiversity we see today. From this point onward, life's evolutionary journey would be marked by periods of diversification, adaptation, and sadly, extinction. This is Section 8, When Life Almost Ended, Tales of Mass Extinctions. The history of life on Earth is not a linear progression, but a story of resilience and adaptation in the face of catastrophic events. Throughout its long history, Earth has witnessed several mass extinctions, periods when a significant portion of life was wiped out. These mass extinctions, often caused by asteroid impacts, volcanic eruptions, or rapid climate change, reshaped the course of evolution. While devastating, these events also created opportunities for new forms of life to emerge and thrive. Each extinction event, like a reset button, allowed for new evolutionary pathways to be explored, leading to the incredible diversity of life we see today. Section 9. Climbing the Ladder of Evolution, the Long Road to Humanity. Among the survivors of these ancient extinctions were a group of mammals that would eventually give rise to our own species. These early mammals were small, nocturnal creatures that lived in the shadow of the dinosaurs. However, when the dinosaurs were wiped out 66 million years ago, mammals seized the opportunity to diversify and evolve. Over millions of years, they adapted to various environments, giving rise to primates, our distant ancestors. These early primates possessed grasping hands and feet, binocular vision, and larger brains, traits that would prove crucial for their descendants' success. The stage was set for the next chapter in our story, the emergence of humans. Section 10. A moment in time. Humans and the future of our planet. From early primates, hominids emerged, walking upright with larger brains. Around 300,000 years ago, Homo sapiens appeared on the African savanna. With language, tools, and complex thought, humans have transformed our world. However, our impact has come at a cost. We face a global climate crisis and biodiversity loss. The choices we make today will determine the fate of countless life forms.